Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper trending on X, published on October 30th, 2025, about 3 days ago. It turns a two-frame, 3D-grounded correspondence model into a point tracker that needs no temporal context, yet scores 73.8 delta average and 85.8% occlusion accuracy on TAP-Vid-DAVIS, close to County Tracker 2 at 75.7 and 88.3, and it beats County Tracker 3 on EgoPoints 61.3 versus 54.2, and on RGB-S 87.0 versus 82.8. The paper is titled PointSt3R, Point Tracking Through 3D-Grounded Correspondence. And as we will see, the implications for robust tracking without video context are quite significant. Alright, Figure 1 compares County Tracker 3, PointSt3R, and PointSt3R on 4 frames from a TAP-Vid-DAVIS clip. The blue dots mark ground truth, and the red dots show predictions. PointSt3R drifts on the moving dog, with long mismatched trajectories because its training favors static scenes. PointSt3R aligns closely with the blue dots across frames, performing on par with County Tracker 3 while using only pairwise correspondence. Alright, Figure 2 visualizes feature maps for 2 frames, revealing how each model encodes motion and background. Co-Tracker 3 shows locally sensitive patterns that highlight the moving cart and the scene together. PointSt3R produces smooth, globally consistent colors that align with the 3D static background, which suppresses distinct features on the dynamic cart so tracks get lost. PointSt3R blends both behaviors, retaining global structure while adding local detail, so dynamic objects remain identifiable across frames. So, Figure 2 contrasted feature styles, and Table 1 now quantifies the gap between static and dynamic tracking. The table reports 2 datasets split into static and dynamic points. PointSt3R leads on static EgoPoints at about 79, well above County Tracker 3 at 65, while on static point, Odyssey County Tracker 3 tops the chart at about 83, and PointSt3R scores 67. On dynamic points, County Tracker 3 dominates, around 50 on Point Odyssey and 36 on EgoPoints, whereas PointSt3R lags near 25 and 12. So, the previous table contrasted static and dynamic difficulty. Table 3 reports occlusion accuracy on TAP-Vid-DAVIS. Occlusion accuracy measures whether the tracker correctly predicts if a point is visible, which is crucial because false visibility claims break long tracks. Co-Tracker 3 leads at about 90%. County Tracker 2 follows at about 88%, and PointSt3R reaches about 86%. That result is notable because PointSt3R uses only pairwise frames. So, the previous table covered occlusions, and Table 2 reports tracking accuracy delta average across 4 benchmarks. The table shows PointSt3R leading on RGB-S at about 87 and on EgoPoints at about 61, while matching RoboTap near 79 and staying close on TAP-Vid-DAVIS at about 74. The upper block lists temporally informed trackers, and the lower block lists pairwise correspondence models. On dynamic-only splits, PointSt3R trails County Tracker 3, but remains competitive and clearly surpasses PointSt3R. Okay, the previous table summarized benchmark scores, and Figure 3 probes why training works. The left panel shows delta average rising as the share of dynamic correspondences increases, with gains across Davis, RoboTap, RGB-S, EgoPoints, and Point Odyssey relative to the dashed PointSt3R baselines. The middle panel stays strong on static points until a sharp drop at 100% dynamic, which signals forgetting of 3D grounding. The right panel climbs steadily on dynamic points, so roughly 90 to 95% dynamic gives the best balance. Wrapping up, 2 takeaways stand out. A 3D-grounded, 2-frame matcher can track points competitively without any temporal context, and training with mostly dynamic correspondences, plus a visibility head, delivers the balance between motion and geometry. The broader implication is faster, simpler tracking for robotics, augmented reality, and video editing. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.